In 1924, Sweden was in crisis. The First World War had drained the country's coal reserves to nothing. Decades of industrial logging had stripped the forests bare. And the Swedish government had just passed new thermal insulation standards for buildings, standards that nothing on the market could meet affordably. The country needed a construction material that didn't exist yet. Into that problem stepped a researcher named Dr. Johan Axel Ericsson at the Royal Institute of Technology in Stockholm. What he did next looks, on paper, like a chemistry accident. He combined limestone powder, water, and a small amount of aluminum powder. The aluminum reacted with the alkaline mixture and released hydrogen gas. Millions of microscopic bubbles expanded through the slurry, the same way yeast raises bread. Then he sealed the entire mixture inside a pressurized steam chamber and cured it overnight at 180 degrees Celsius. What came out was unlike anything the construction industry had ever produced. The blocks were filled with millions of sealed air pockets, locked permanently inside a mineral matrix called tobermorite, the same crystalline compound that forms naturally inside volcanic rock under geological heat and pressure. Ericsson had not invented a synthetic material. He had replicated a geological process in a controlled laboratory environment and made it repeatable on an industrial scale. The blocks were light enough to float in water, strong enough to carry structural loads, and those locked air pockets made them one of the most effective thermal insulators ever built into a wall. He called it autoclaved aerated concrete. The industry shortened it to AAC. Most people today call it Aircrete. Within a decade, Scandinavia was building with it at scale. The material worked. The physics were settled. The only question left was why the rest of the world wasn't paying attention. To understand what AAC actually does, you have to understand what a conventional wall is doing wrong. In standard timber frame construction, wooden studs run continuously from the interior surface of the wall to the exterior surface. Those studs are not insulation, they are wood, and wood conducts heat. Every stud in a timber frame wall is a thermal bridge, a direct physical pathway for energy to travel straight through the wall, bypassing the insulation entirely. The fiberglass bats packed between those studs compound the problem. They compress over time. They sag in humid conditions. The moment air moves through them, their effectiveness collapses. Roughly 40% of a typical home's heating and cooling costs are lost directly through those bridges. The insulation is fighting a wall that was structurally designed to undermine it. An AAC wall eliminates that conflict entirely. There are no studs, no cavity, no gap. The block itself is simultaneously the load-bearing structure and the thermal insulation. Millions of sealed air cells, locked inside a tobermorite matrix, stop heat transfer without compressing, without sagging, and without any dependence on installation quality. The fire performance is in a different category altogether. An 8-inch AAC wall will sit in a 2,000-degree Fahrenheit fire for 4 hours before any structural failure occurs. The timber framing the building code requires in its place burns through in minutes. This is not a marginal improvement. It is a different class of material. AAC is also vapor permeable. The wall breathes. Moisture passes through rather than accumulating inside the assembly, which eliminates the conditions that generate mold in sealed timber frame construction. And the weight. AAC weighs approximately 1/5 of standard concrete block. That reduction cascades through the entire build: smaller foundation loads, lower transportation costs, faster installation with less labor. The block floats. It breathes. It will not burn. It does not compress. It is the structure and the insulation in a single material. The physics have been settled for a century. The performance is documented on multiple continents. The problem was never the material. Open the International Residential Code, the document that governs what Americans are legally permitted to build in most states, and look for AAC. you will not find it. The code recognizes 4 approved structural materials: poured concrete, dimensional lumber, masonry block, and light gauge steel. That is the complete list. A material used in the majority of new homes across Germany, the United Kingdom, and dozens of other countries does not appear on it. Getting something added to that list is not a technical process. It is a political one. It requires an independent engineer stamp, laboratory testing, an ICC evaluation service report that can take years to complete and cost tens of thousands of dollars to commission, and finally, a local building official willing to approve it, a decision that is entirely at their personal discretion. Every step of that pathway costs money that the materials advocates have to spend before a single block is legally placed in an American wall. Now look at who is working the other side of that process. The American Wood Council represents 86% of the structural wood products industry in the United States. They employ approximately 40 staff members working specifically on building codes, standards, and regulations. Their own published data documents that their code advocacy programs have directly influenced nearly 3,000 construction projects and generated almost 12 billion board feet of incremental lumber demand since 2019. That is not lobbying in the abstract. That is a measured, documented return on investment in the regulatory process. AAC has none of that infrastructure. No lobbyists, no code committee staff, no prescriptive mortgage pathway for lenders, no actuarial model for insurers, no comparable sales data for property appraisers. Each institution in the chain, the bank, the insurer, the appraiser, the building official, is doing exactly what it was designed to do. The system is functioning correctly. It was simply never designed to accommodate a material that generates no recurring revenue, requires no maintenance contracts, and does not need replacing. A material you cannot meter is a material the system has no financial use for. This is not a conspiracy. It is a structure of incentives, and every actor inside it is behaving rationally. The rules were written by people who understood exactly what they were writing them for. Which brings us to Florida. In Plant City, a homeowner built a concrete dome structure using AAC principles. Not as an experiment, not as a prototype, as a primary residence. FEMA independently rates concrete dome structures at its highest residential safety classification. They have documented cases, on record, in public filings, of dome homes surviving direct hits from hurricanes, tornadoes, and wildfires, while the timber-framed houses immediately surrounding them were demolished down to the slab. That is what happened in Plant City. Hurricane after hurricane came through. His house stood. The houses around it did not. The structure performs exactly as the physics predict it should. The mass absorbs and distributes lateral wind loads that would tear through a stud wall. The monolithic shell has no seams, no joints, no cladding to peel. There is nothing for the wind to catch and nothing for the fire to consume. The performance is not remarkable. It is simply what the material does. And yet the owner cannot get a conventional mortgage on the property. No bank has a valuation model for a structure with no comparable sales in the surrounding market. Appraisers require comparables. There are none. He paid cash. His energy costs are negligible. His house is standing. That outcome is documented. It is not a theory or an anecdote passed through online forums. It is in the public record, in FEMA's own assessment literature, in the kind of dry government language that doesn't argue or editorialize. The federal government has documented that this construction method produces the most hurricane-resilient residential structures in the country. That same federal government finances 90% of American home purchases through a mortgage system that has no pathway for the material. That is not an oversight. That is the system working as designed. AAC is not banned in the United States. That distinction matters. It is excluded from the prescriptive pathway. the straightforward, low-friction route that most contractors and developers use because it requires no additional approvals, no engineering review, and no discretionary sign-off from a local official. Exclusion from that pathway is not the same as prohibition. But in practical terms, for most builders and most homeowners, the effect is nearly identical. The alternative materials pathway exists, with a licensed engineer willing to stamp the plans and a building official willing to review the submission. AAC can be approved and built today. The barrier is not legal. It is procedural, financial, and deeply dependent on local jurisdiction. Some jurisdictions make this significantly more accessible than others. Unincorporated rural areas in Arizona, Texas, and New Mexico operate with minimal or no residential code enforcement. New Mexico goes further. The state has explicit codes for alternative construction methods and a sustainable building tax credit that directly offsets the additional approval costs. In those locations, this is not a future possibility. It is buildable right now. The global context makes the American situation harder to dismiss as simply cautious regulation. Germany builds 60% of its new homes with AAC. The United Kingdom, 75%. India is actively constructing 60 million homes with the material at this moment. At that procurement scale, AAC is cost competitive with timber framing on a straight per square foot basis. The premium in the American market is not in the material. It is in the approval process that surrounds it. For anyone not ready to commit to a primary residence, AAC block is commercially available in the United States today. It can be used without structural code approval for workshops, outbuildings, and garden walls. That is not a consolation prize. It is direct, hands-on experience with a material that most American builders have never touched. Erickson solved the problem in 1924. The material has not changed. The question has always been whether the system around it would. Johann Axel Ericsson walked out of a Stockholm laboratory in 1924, holding a block that outperformed every material the building industry was selling. A century later, billions of people on multiple continents build with it. In America, it has no seat at the table. The system is not broken. It is working exactly as designed. The only question worth asking is designed for whom? Your home is the largest financial and physical investment you will make in your lifetime. You deserve to know what the building code is not telling you. The information exists. The material exists. The decision is yours.